Good morning children, Sairam. Children, this is the physics video for 10th class and here we are having our chapter number 2, magnetic effects of electric current. You will learn about magnet and its properties and the current which is produced due to the action of magnet. What magnet is actually? Magnet is an object that attracts objects made of iron, cobalt and nickel. When it is suspended freely, it comes to rest in north to south direction. Magnetic field. It's the space around a magnet in which the force of attraction or repulsion can be detected. It is a vector quantity and its SI unit is Tesla. Now, magnetic field lines. These are the curved paths along which the iron filings arrange themselves due to the force acting on them in the magnetic field. They are also called as magnetic lines of force. These lines always begin from North Pole and end in the South Pole of the magnet. Now, magnetic field lines pattern due to a bar magnet. Children, here I am showing you the diagram or picture which is showing you the bar magnet. In this picture you can see we are having a bar magnet. This is the bar magnet which is in bar shape and this bar magnet is having two endpoints. First end which is showing the North Pole and the second end point which is showing the South Pole. So a bar magnet is having two poles, North Pole and South Poles. And the magnetic field lines which a bar magnet is producing, they always start from north direction and where they are ending, they end at South Pole. So here we are showing the direction of magnetic field lines. You can see here from where the magnetic field lines are starting, they are starting from north and where they are ending at south. So these are the magnetic field lines and these magnetic field lines, they are forming a pattern which we are able to see in a bar magnet. Now these magnetic field lines are having their characteristic properties. The properties are as the magnetic field lines originate from the north pole of magnet and ends at its south pole. The magnetic field lines come closer to another. Children, here this is the typing mistake. The magnetic field lines come closer to one another near the poles of a magnet, but they are widely separated at the other places. The magnetic field lines do not intersect one another. If two magnetic field lines intersect, there would be two directions of the magnetic field at that point, which is not possible. Now, the magnetic effect of current, which is also known as electromagnetism, means the conduction of electricity by a magnet. The magnetic effect of current was discovered by Ørsted in 1820. He found that a wire carrying current was able to deflect a compass needle. A current flowing in a wire always gives rise to a magnetic field around it. Magnetic field pattern produced by a current carrying conductor. If we are taking a straight wire, then the pattern will be different. If we are taking a loop wire, then also the pattern will be different. So here you can see different patterns for different types of wire. So in first case, we are taking a straight wire. The magnetic field lines around a straight wire are concentric circles whose centers lie on the wire. Now I am showing you the diagram. If we are taking a straight wire, it's a straight wire which is having current in this direction. If magnetic field is produced, if we are connecting this wire, the two ends of wire with the battery, then current will start flowing. And as the current is flowing here, the magnetic field lines are producing here. And how these magnetic field lines are producing? They are in concentric circular form. Okay. Maxwell's right hand thumb rule for direction of magnetic field in a straight wire. Children, you have seen how the magnetic field line pattern is forming. But if you want to find out the direction of magnetic field, how you can find out? To find out the direction, we can use Maxwell's right hand thumb rule. It states, imagine that you are holding a current carrying straight wire in your right hand so that your thumb points. Children, here also it is not thumbnail, it is thumb. So that your thumb points in the direction, then the direction in which your fingers, in which again children it is concentric circle. Okay, these are in which your concentric circle, in which your fingers, it will be in which your fingers encircle the wire. Okay, so I am just reading this line again. Then the direction in which your fingers encircle the wire will give the direction of magnetic field. You can see here we are holding a wire in this way. Right hand thumb rule we are applying. The direction of current is in this way, and the concentric circles are forming around, means the fingers which are surrounding, that is showing the direction of magnetic field. In a circular wire or loop, the magnetic field lines are circular near the current carrying loop. As we, now children here also, as we move away, it is move away. As we move away, these concentric circles become bigger, and at the center of the loop magnetic field lines are straight. Here you can see the diagram. What we are seeing at the ends, we can see the circular pattern. This is the second end, circular pattern is forming, and at the center we can see the straight magnetic field lines are forming. Now the next one is in a solenoid. Children, what a solenoid is, it's a coil of many circular turns of insulated copper wire wrapped closely in the shape of cylinder. You can see here this is the diagram of solenoid. The magnetic field in a solenoid is similar to the magnetic field produced by a bar magnet. Means if you want to make a pattern, you have to make the same pattern which is forming in a bar magnet. You can see here we are having our solenoid. This is the solenoid, and around this we are having different turnings, many turnings, copper turnings, and how the magnetic field is producing in similar way as it is forming in bar magnet. So you can see this thing here. Now children, after this I am just providing you assignment. The questions are: define magnetic field. Why don't two magnetic field lines of force intersect each other? State Maxwell's right hand thumb rule. And the last one is: name the scientist who discovered the magnetic effect of current. As I am finishing this video, finish all your written work in your notebook. Thank you, Sai Ram children.